This is Mrs. O'Neill for AP Chemistry, Chapter 13, Section 2, Saturated Solutions and Solubility. You're going to learn that when a saturated solution is in contact with undissolved solute, the dissolved and undissolved solutes are in equilibrium. That equilibrium word, and one day we will get to that chapter. Determine the amount of solute in a saturated solution really defines the solubility of that solute, the extent to which a particular solute dissolves in a particular solvent. And soon you're going to see a chart that actually has many different salts, many different ionic compounds, and how they would dissolve in water, but it's based off of temperature. So pause, fill in the blanks, and then listen, and then play to hear my words. Solubility is just that, the quantity, the amount of a particular substance that can dissolve in a particular solvent. So how much salt can we dissolve in water? And it's really based off of the temperature of that water. So crystallization is the opposite of the solution process. That's how you can make rock candy. So if you take this reaction, or I like to say process, we just like to represent it like a reaction. We take some salt, we add it to water, and we get a solution. That's called dissolving. But can we take that solution and go backwards? Absolutely. That's what rock candy is, and then we crystallize. So this is one of the reasons, this equilibrium symbol in the process or the reaction, that's why we can taste salt. You have salt in salt water, so the Na plus and the Cl minus, at some point they're going to come together and form the salt NaCl again. So that's why you actually can taste salt in your salt water, because not all of the salt molecules are actually breaking apart into those ions. Some of them will recrystallize back into the NaCl. So what's the difference between a saturated solution, an unsaturated solution, and a supersaturated solution? Well, a saturated solution means that the solution's at equilibrium. We can no longer dissolve any more solute. No more will dissolve. If we put any more in, we're going to start seeing the crystallize. It's not going to be able to dissolve anymore. Unsaturated is the amount is less of that solute. So we can keep adding and adding and adding until we get to the saturation point. So when we add salt to water, it's going to be unsaturated until we get to what's called the saturated line. And again, we're going to talk about that when we see the graph soon, and that's going to be saturation. That's going to be where there's an equilibrium. But then if we continue to add, right, dissolve more of that solute than the amount needed for that saturation point, that's going to be called a supersaturated solution. And yes, you can get a supersaturated solution, again, because of the temperature. If I keep adding salt to water, it's going to dissolve up to a certain point, but then I can heat it up. And if I heat up that solution that I've already made and add more salt, I can dissolve more. So I get that supersaturated solution, and as it cools down, that's how we get that rock candy. That's how we can do that. So in other words, we have something like the solubility of salt here in water at 0 degrees Celsius is 36 grams per 1 milliliter. So what does that mean for 36 grams of the solute must be absorbed by that 100 milliliters of water at that temperature before anything else can occur? So here we have a beaker. We've added 50 grams of salt, and we're going to consider this unsaturated because I don't see anything in here. But now let's look at this. 30 more is poured into the solution, and all of it still dissolves. Now, how do I know this is saturated? Because if I add another 10 grams, only 4 of that undissolved solute is going to remain. So only 6 dissolved and 4 remains. Now I have what's called a supersaturated solution. And again, when the rest of the salt is poured, again, 14 of it is now undissolved, and we have what's called a supersaturated solution. So what happens in this supersaturated solution is when we add a crystal, we can actually see crystals growing because like that rock candy, it grows on itself as it cools down. So think of a sponge. This is a nice analogy of a sponge that's unsaturated because you can still get more water in there. At some point, the sponge is going to be saturated. I put so much water in there, but one more drop and now it starts to seep out, and that would be supersaturated. So when it's saturated, we're going to think of the equilibrium symbol to know that the solute and solvent are in equilibrium with that solution process. And our supersaturated solution can also be called crystalline. We're kind of crystallizing out. See you in class.